The fifth experiment in our syllabus is measurement of inductance using Maxwell Bridge. The objective of this experiment is to understand the working principle of Maxwell Bridge and its application in measuring inductance, to study the construction and configuration of the Maxwell Bridge circuit, and to accurately measure the inductance of the unknown inductor using the bridge balancing technique, to analyze the phase relationships between the current and voltage in the bridge circuit during the experiment, and to practice the method of balancing the bridge by adjusting the resistance and capacitance to achieve the zero deflection on the null detector, and to calculate the inductance using the bridge balance condition and analyze the source of errors in the measurement, and to gain the practical experience in using AC bridges for impedance measurement in electrical and electronic systems, and to verify the theoretical formula for the inductance measurement using the experimental data.
So here is the trainer kit for Maxwell inductance bridge. So there is a decade inductance bus to which is we are choosing the decade inductance part for the unknown inductance. There are various values are there. So patch cards are used for the connections in the circuit and the trainer kit, and multimeter is used to measure the unknown resistance. So supplies for this AC bridge is given as a 1 kilohertz frequency from the oscillator. So for this A to A supply is given A to A and B to B, and we have to give the connections to the daughter lines, short the daughter lines using patch cords. So this daughter line should be connected using this patch cords. Similarly, there the R1 arm, and we can there are multiple values of R3 like 10 ohm, 100 ohm, 1 kilo ohm. We can choose based on our inductance. The unknown inductance is connected in the RX LX arm. So there will be internal resistance. We will be connecting the decade inductance. From the decade inductance bus will be connected the unknown inductance. So the value of C1 is 0.1 microfarad, which is fixed. So we have to measure. So the red arrow is connected to this audio amplifier. When there is no flow of current, the audio will be very low. Okay, to make the balance bridge, will be varying the R2 values using this part. So now we are going to give connections from A to A. After A to A, then we need to give B to B. Then we have to give connections. We have to short the total lines. We are short circuit the total lines. Then we are giving the detector to audio amplifier. So during this, when there is no flow, the audio amplifier sound will be reduced, and we are choosing the value of R2. Okay, now the connections are over. So there is a one more connection from the decade inductance bus, which the unknown value of inductance is to be measured. Okay, so we can fix the value of this unknown inductance as 3. Okay, now so by varying this R2, we will be making this delta should be a 0 1. Okay, now switching the circuit by varying the potentiometer, we need to make the value as 0. We are varying the value of R2 now. So by adjusting the value of R2, we are making the value of detector should be 0, or we can observe the noise of audio amplifier to be 0. Now we are going to measure the value of for R1 and R3. So first we are removing the patch cons in the R1 amp to measure the value of R1. So to measure the value of R1, so in the R1 arm we are switch offing the circuit and we can measure the value of R1. From the circuit we have to note the value of R1 and R3 and R2. So R1 and R2 are the variable resistance which we are finding by this potentiometers, and R3 will be is the by the selection of the patch cards. Now we are measuring the value of R2 in this, um, and already we will be noting the value of R3 from the patch card values. So after tabulate the readings, we need to do calculations. So there is the formula for to measure the unknown inductance. Lx is equal to R1 into R3 into C. We have noted the value of R1 and R3 and capacitance from this circuit. So R1 is 2 and R3 value is 1 kilo ohm and C is 0.1 farad, so that we can able to calculate the inductance as 2 into 1 into 0.1 as 0.201 Henry. The unit of inductance is Henry. So Rx, the value of, after that we are finding the value of quality factor Q is equal to omega into Lx by Rx, where omega is equal to 2 pi f. The frequency which is f is equal to 1 kilohertz, so we are putting 1000. 2 pi into 1000 into the value of Lx is equal to 0.01. The Rx value is 0.613 and the quality factor is calculated as 2.059.